All right, let me get my face out of the way. Okay, so we have tension on our rope between two objects. We can do this. We can do this. Okay, so we know that our 40 kilogram block, when in doubt, draw free body, right? We've got mg down, we got normal up, those balance. Because if they didn't balance, that means we're either sinking into the table or floating above it, and we're not, so those have to balance, so we don't really care about those. Going sideways, we have some sort of force. I'm going to call it capital T for tension. Okay, and then the other block, so we have the 40 kilogram block. The 10 kilogram block, we've got normal up, mg down. We have this applied force of 50 newtons to the right, and we have tension to the left. Okay, this is the exact same amount of tension that's on this guy on the 40 kilogram. If they didn't match, then your rope's broken. That's how ropes work. They have to match. So this tension, where's my mouse? This tension and this 50 newtons, those don't have to match. If they match, then we wouldn't be moving. But the tension coming to the left, going this way and going this way, those have to match. If it's the same rope, has to match. So let's figure out what this tension is. So I'm going to draw a free body of something that maybe you haven't drawn yet ever, and that's the free body of the system. The system, man. So the system, I want to treat it like a dot. So this system has both boxes in it, and both boxes, the net force is 50 newtons to the right. We've got gravity down, normal up, whatever, they cancel out. The net force is 50 newtons to the right. So let's do F equals ma to figure out how fast is the system going. Well, the net force is 50. The total mass of the system, you have to add those up. So 40 plus 10, that's 50. And that'll get us our acceleration. So the acceleration is 1 meter per second squared. So now, to figure out this tension, we use the fact that acceleration equals 1. Because if the system's accelerating at 1 meters per second, that means this block has an acceleration of 1 and this block has an acceleration of 1. Neither of them is going to win. They have to accelerate together. All right, so they have all the same acceleration as the system. Okay, so we do F equals ma again, this time for the 40 kilogram block. The net force, we don't know, it's just tension. But the mass is 40 and the acceleration is 1, so that tension has to be 40 newtons. That's how you know. So the answer is 40 newtons. If you want to take it over here and try to confirm it, that's okay too. So we go F equals ma. So the net force on this guy, this is going to be 50 minus t, right? Because we have 50 going to the right, and that's what's pulling us along. And then we have tension holding us back. This 40, I'm touching my screen you can see that. But the 40 kilogram block is slowing us down. It's not winning. The 50 Newton force is winning, which is why we're going that way. But it is going the opposite direction, which is why we subtract. The mass of just this block is 10, and the acceleration of the system is 1. So 50 minus t has to equal 10. Well, that means t has to be 40. So that's another way to see that tension has to be 40 newtons. Okay, that's the way.